Okay, welcome to Lesson 6 of Module 6. This is scatter plots, and we're going to use what we have been exploring about increasing and decreasing functions, and we're going to look at plots of real data, so data from real-world examples, and we're going to try to see if there's a relationship, what relationships we can learn about through looking at the data. Okay, so here's our first example. So there's some new terms here for you. Bivariate is something you might not have heard before, and you'll want to think about what that word could mean. And I wish I was there with you, because I'm sure you would come up with, looking at the roots of the word, you definitely see the root for variable in there. And you know that the root bi from bicycle means two, so bivariate means two variables. So this is a data set with two variables, and it consists of observations on two variables. So observation is another word that we'll be using in a different context maybe than you're used to. But an observation is just a measurement, so it's a pair. So each observation in the data set will be an XY pair. Okay, so in this example, our X variable is going to be weight in pounds of a car. So we've got 13 different models of cars. They each have a weight, and they each, their fuel efficiency can also be measured. So we want to see if there's a relationship between weight of a car and its fuel efficiency. So our Y variable will be the fuel efficiency measured in miles per gallon, and the weight is rounded to the nearest 50 pounds. But so here's a table with data for. They all have automatic transmissions, and they're all manufactured by Chevrolet in 2009. A lot of the data that you'll be doing in this lesson comes from a specific source, and sometimes it's cited. So, okay, so let's move on to the next question. Okay, so exercise 1 says, in the table above, the observation corresponding to Model 1 is 3,223. What is the fuel efficiency of this car? What is the weight of this car? Okay, so just fuel efficiency would be 23 miles per gallon, and the weight of the car would be 3,200 pounds. Okay, so just making sure we understand what those numbers are standing for. Whoops. Okay, so what we want to do now is add the points corresponding to the other 12 observations to the scatter plot. So we could look at the next one, which is 2550 in weight and a fuel efficiency of 28. So let's see if we can get that one on here. 2550 would be, use my arrow, 2,500, and this is 3,000. So each of these is standing for, that's what we need to figure out. How much does each of these little lines stand for? So the distance between here and here is 500, and there are 1, 2, 3, 4, 5. It looks like there's about 10 lines. So we're going to go with each of those being 50. So it's kind of difficult, and they're not real even. But so 2550 is right about here. And I'm going to go up to a fuel efficiency of 28. So that dot would be right in that area. 28 and 2550, somewhere around there. Okay, so you're going to do that with the other, the rest of the data set. Pause the video And then what we're going to be asking ourselves is this answer to this next question. Do you notice a pattern in the scatter plot? What does this imply about the relationship between weight and fuel efficiency? So between X and Y. Okay, so go ahead and pause the video and work on that. Okay, so here's the data plotted. Here should look something like that. Okay, so hopefully you thought about what the relationship between weight and fuel efficiency would look like, and noticed possibly that this appears to be a decreasing function. Like if I thought about putting a line straight through here, that as the weight of the car increased, the fuel efficiency decreases. Okay, so that is a fairly noticeable pattern in this scatter plot. Notice that our heaviest car doesn't have our lowest, here's the heaviest car, it doesn't have the lowest fuel efficiency. But in general, as the cars get lighter, their fuel efficiency increases. Okay, let's look at the next set of exercises. We have some more data. This looks like it's from Consumer Reports. And it asks, is there a relationship between the price and quality of athletic shoes? The data in the table below are from the Consumer Reports website. So we're going to have two variables again. This is a bivariate data set. So our first variable is going to be price, and that'll be the price in dollars. And the second variable, Y, is going to be the quality rating given by Consumer Reports. So the quality rating is on a scale of 0 to 100, with 100 being the highest quality. One observation in the data set is 157. What does this ordered pair represent in terms of cost and quality? 100, 110, 57. So this would be shoes that cost, this would be cost of shoes is $110. Quality rating would be 57. Okay, so just keep in mind what the X and the Y are standing for. And so it says to construct a scatter plot of these data, you need to start thinking about appropriate scales for the axes of the scatter plot. The price in the data set range from $30 to $110. So one reasonable choice for the scale of the x-axis would range from 20 to 120, as shown below. So notice this is one where they're not starting at 0. Probably could have with this data starting at 20. It wouldn't be much different. But they're thinking about what is the lowest price shoe. I don't need this part of the scale because I don't have any shoes in that price range. And making sure I can fit my most expensive pair on here. So your job is to think of what would a reasonable scale be for the y-axis. What do I want it to go from what to what? So first think of that and then we'll construct it. Okay, so hopefully you went back to your data to see what kind of range of values the quality rating has. So it looks like the smallest one is 51. right here, and the largest one is 71. So the quality rating goes from 51 to 71. So maybe we would want our scale to go from like maybe 50 to 75. So that would include everything there. So we want it to go from 50 to 75. So we need to think about how is that going to fit here. So we probably would, since there's nothing between 0 and 50, we could start our 50 somewhere in here and then count it off so that 75 ends up somewhere about right there. So that's going to be your process there. So think about that, and I'll show you a completed. And then number 6 says add the scale to the y-axis, then use these axes to construct a scatter plot of the data. So then you're going to plot all the points. So work on that, and then come back and we will talk about the last 2 questions together. Okay, so here's a completed scatter plot. Yours could look a little different depending on where you placed your 50 and your 75. So don't worry if yours looks a little bit different, but it should look fairly similar to this. And so let's look on. So number 7 asks, do you see any pattern in the scatter plot indicating that there is a relationship between price and quality rating for athletic shoes? So there could be some different answers for this question. So I want you to think about it if you haven't already and write out what you see in this data. Okay, so when I look at this data, I pretty much don't see a relationship between price and quality. This set of data doesn't show that if I spend more money on a pair of shoes, that I'm going to get a better pair of shoes. That would be points up in this region. So there's like basically no points up here. So that tells me that relationship doesn't hold. However, I could maybe, if anything, see that the quality tends to go down if my price goes up. But so either of those ideas would be correct here. So if you said no correlation between price and quality, I would accept that. Or if you said maybe a slight downward trend in quality as the price increased, then that would be reasonable too. These data tend to support both of those things. So that would be the answer to number 7. And then number 8 says, some people think that if shoes have a high price, they must be of high quality. How would you respond? Okay, so you might respond just by saying that this set of data doesn't support that idea. There could be, but not according to this study that was done. So it's always important to, whenever you try to make conclusions from a set of data, we might need to confine it to this set or this particular study. We can't say anything in general about all shoes, but for this study of athletic shoes, there seems to be no correlation or a downward trend in quality and with price. Okay, let's look at the next example. Okay, this next example points out something important about interpreting these types of scatter plots. Okay, so let's just read it. A pattern in a scatter plot indicates that the values of one variable tend to vary in a predictable way as the values of the other variable change. This is called a statistical relationship. So with fuel efficiency and car weight, fuel efficiency tended to decrease as car weight increased. This is useful information, but we must be careful not to jump to a conclusion that increasing the weight of a car causes the fuel efficiency to go down. So you can't really have, you can't support a cause-effect relationship because there could be other things going on. So there may be some other explanation for this. For example, heavier cars may also have bigger engines, and bigger engines may be less efficient. You cannot conclude that changes to one variable cause changes in the other variable just because there is a statistical relationship in a scatter plot. Now, this is something that will be, really important to you in real life in interpreting articles that you read or, data that's out there in the real world. People will try to say that, X causes Y when there's just a relationship between X and Y, but there can be very complicated relationships. So let's look at this next example. This next example, exercises 9 and 10, says data were collected on shoe size, which will be our X variable, and score on a reading ability test, and that will be Y. Y will be the score on the test for 30 elementary school students. The scatter plot of these data is shown below. Does there appear to be a statistical relationship between shoe size and score on a reading test? I got excited about this one because I have big feet. But yeah, there does. There is a statistical relationship here, right? This appears to be an upward trend. As shoe size increases, reading ability increases. All right? So number 10 says, explain why it is not reasonable to conclude that having big feet causes a high reading score. Okay? So does increasing shoe size cause your reading score to go up? Can you think of a different explanation for why you might see a pattern like this? Okay, so if you have somebody there to discuss this with, maybe you should pause the video and do that. Okay, so what did you come up with? What could be some reasons why increasing shoe size causes reading score to go up? So maybe you thought, when I first read this, I thought, well, it was everybody would have been in the same grade, right? Everybody would have been in the same class. But it just says elementary school students. So probably these kids with the bigger shoe size are in a higher grade. They're older. These are older kids. They've been reading longer. Their reading ability increases with their age, not necessarily with their shoe size. So there is a statistical relationship between these two variables, but not a cause-effect relationship. So this is a huge lesson for you when you're reading articles and somebody's using data to make a point. You need to understand more than just maybe the one study. You need to understand who was in this study, what did they do, and so on. But so hopefully you've seen in this lesson that scatter plots are a really useful way of looking at data and being able to visually see a trend. Whereas if all you have is a table of values, sometimes it's hard to sort it out. The visual of a scatter plot can really help us. There's one other funny example in the teacher notes here that I want to share with you on this idea of a statistical relationship, but not a cause and effect relationship. And it is that there's a statistical relationship that says that on a beach, that as the ice cream sales increase, when there's more ice cream sales, there are more people who need to be rescued by lifeguards. So could we conclude that it's the higher ice cream sales that cause more people needing to be rescued? Or is there something else going on there that could explain why those two variables have a statistical relationship like that? So probably you would say that when the temperature is high, both of those variables are going to have a high value. More people on the beach when there's warmer temperatures, also more people eating ice cream, and therefore when there's more people on the beach, there's probably going to be more rescues. So there's not a cause and effect relationship there between ice cream and lifeguard rescues, but there definitely is a statistical relationship. Okay, so let's look at the summary. So a scatter plot is a graph of numerical data on two variables. And remember we said that word two variables we're going to use bivariate. A pattern in a scatter plot suggests that there may be a relationship between the two variables used to construct the scatter plot. If the two variables tend to vary in a predictable way, we can say there's a statistical relationship between the two variables. But a statistical relationship between two variables does not imply that a change in one variable causes a change in the other variable, and that's the important concept there, that causes a change. We'd be talking about a cause and effect relationship there. So, okay, so good luck on the problem set with this one. I think you'll be constructing a couple data plots and interpreting the relationship between the variables in this. Actually, maybe just one. No, there's more than one, there's two. Okay, so have fun with that, and we'll see you back here for lesson 7.